Hello everyone. Today we are going to solve this difficult level statistics problem that was posted in my WhatsApp and Facebook groups as part of daily practice problems. Hi everyone, I'm going to pause the video here to give a very important message. To get the maximum value out of this video, after you have viewed the solution, I would recommend you pause the video, get a notebook, go back to the question and solve it by yourself. Whatever you have learned in the video should be fresh in your mind, and that would be the best time to actually reinforce that learning by solving the question by yourself, and make sure you are able to solve the question by yourself without getting stuck again. So please follow this recommendation to get the maximum benefit out of this solution. Let's continue. And I usually talk about the wrong approach to do a question and a right approach to do the question, trying to highlight what mistakes people make. But this question is a little bit different. And the problem that people usually face with this question is about moving forward. They are stuck. They don't know how to move forward. So we'll talk about how to get unstuck in questions like this in a step-by-step manner, and then we will go on to actually solve this question and get to the right answer. If you would like to be part of my Facebook group or WhatsApp group, or you have any comments or doubts about this video, please leave a comment below. If you find this video helpful, please do not forget to like the video and subscribe to my channel. It helps me a lot and keeps me motivated to keep bringing these free videos for you. Okay, so let's get started on how to get unstuck on this problem. Okay, let's read through the question first and understand what and where people usually get stuck. So S is given to be a sequence of numbers, and it is also given that it has more than two observations. Now observations is a little bit confusing language, but all it means is it has more than two numbers in the series or the sequence. The mean of the sequence is given to be Y, and we are asked to find the standard deviation. Now we are asked to find a value of standard deviation, not whether it is 0 or not. So it is not a yes or no kind of question. You have to be able to find a unique value of standard deviation. That's where the trick of this question lies. Okay, so let's just unpack the statement of the question a little bit before we go on to the sentences. So we are given that there are more than two observations. So let me just mark those observations as circles for now because we really don't know. So it has to be 3 or more, right? More than 2 means 3 or more observations. The mean is given to be Y, which means the sum divided by n is equal to Y, which also means that the sum of the observations is n times Y. Whatever that number n is, and n has to be 3 or more. So let me write that down as well. N is greater than or equal to 3, and we are asked to find the standard deviation of S. Now nothing is given, so what is the formula for standard deviation? Let's think about that, right? So standard deviation formula is under root of whatever the first observation is minus the mean, which is here given to be Y whole square, plus, so basically the sum of the squares of the difference between different observations and the mean divided by the number of observations. So to find a unique value of standard deviation, we need to be able to have this value n. We need to have the mean. We also need to have different values of the observation, x1, x2, and things like that, so that we can find the difference between them and the mean and square them up. So is there a way to find that? That's basically what the question is talking about. Now in statement 1, the question says the range of the sequence is Y. Now this may look like it is insufficient to answer the question, but let's unpack it a little bit, and this will also come down to how to get unstuck here, because starting to visualize this starts becoming a little more difficult as you go into statement 1. We are given that the range of the sequence is Y. We are also given that the mean of the sequence is Y. So how do you think about that, right? So range of the sequence is basically max number minus minimum number is also given to be Y. We know that the mean is given to be Y. We know that the number of observations is more than 3, but how do we proceed from here? What can this tell us about the standard deviation? Does this information give me anything about the observations? Those are the questions that you should be thinking about at this point, and that is exactly the point where you get stuck, because you don't know the observations. You know the difference between maximum minimum, but how does that translate to what do these observations look like? Okay, here is how you would proceed in a situation like this. You know there is more than 3 observations, but let's start simple. Let's start with any 3 observations, right? So we know that the first observation, let's say, is x. The first number in the series is x, and there are only 3 numbers in the series. So given that the range is y, my largest number in the series would be x plus y. I don't know anything about this middle number. I can assume either x or y. Since the mean is y, right? It may make sense to make the mean as y here and just assume it to be y, or I could count it as x. That is up to you. Either pathway is absolutely fine. So let me just take, for the sake of it, x, because I don't want to make any assumptions with respect to what has been given to me. So these are my 3 observations. What is also given to me is that the sum of them equals n times y, and n is 3 here. So I can equate this. So x plus the sum of the series equals 3 times y, which means 3x equals 2y, and x equals 2y by 3. So this sequence becomes 2y by 3, 2y by 3, and 5y by 3. You can double check, and what you would find is it will absolutely satisfy the 2 conditions that are given to us, that the range is y and also the mean is y, right? However, we assumed n to be 3. N could have been 4 or 5, right? And the sequence could be anything. At this point, we don't know 2 things. We don't know what is real value of n. And obviously, even though x equals 2y by 3, we still don't know what the value of y is. Since our standard deviation depends on this y, because even when you subtract x minus y, you would get a fraction of y, 2 by 3 multiplied by y, or 1 by 3 multiplied by y squared in the numerator, and there is still this n in the denominator. So if you have a series of 3, you would have 3 in the denominator. If you look for a series in 4, you would look for 4 in the denominator. Just to make sure we have covered all the bases, I will just take a quick example of a 4 observation series. Let's just call it this series, where we have the first 2 observations as x, the other 2 observations as x plus y, and we do the exact same thing. So we will get 4x plus 2y equals the new mean, so 4 times y, and we get x equals y divided by 2. And you can rewrite the series as another series, and as you can tell, it would be another standard deviation depending on what the value of y is. Now this is very crucial approach. So even though we were not able to really solve number 1, we figured out 2 things. One, that statement number 1 is not going to be sufficient, because even though we were able to express everything in terms of y, the number of observations is not given to me, and also y is not given to me. So unless I know something about y, my standard deviation is going to depend on both those 2 things, y and n, and hence statement 1 is going to be insufficient. I also figured out a way to move forward, because I know how to express this sequence in terms of its mean, and that is a big deal. So let's go on to statement number 2 at this point. Okay, so in statement number 2, we have to kind of forget about what has been given in statement number 1. However, let's just keep in mind how we got unstuck in statement number 1 with the help of some of the equations that we had to write. In statement number 2, it is given that the smallest observation in the sequence is 0, right? So that is okay. We are given that the smallest observation in the sequence is 0 and nothing other than that, except that the mean is y. So the way to think about this is mean lies somewhere in the middle of all the numbers in the sequence, somewhere in the middle, right? So if I have different numbers here, mean is somewhere in the middle, right? A small number will pull the mean down, a large number will pull the mean up, but mean has to be somewhere in the middle of the numbers, unless all numbers are same, but we'll get to that. So let's assume this number is 2y here, right? So the mean could be y. We could have a situation where we have 0, y, y, 2y as our sequence in each of these cases. As you can see, since n is different, depending on what the value of y and n is, the standard deviation would be. So statement number 2 is also clearly insufficient, right? So now let's combine these two statements and see if that helps us answer the question a little bit. Okay, so let's combine the statements 1 and 2. And let's see if that helps us answer the question. So for statement 1, if you recall the kind of equations we came up with, we started with x, and x plus y. And by equating this to the mean, x is going to be 2 divided by 3y, which gave us this sequence, right? Now, we are also given that the smallest observation in this sequence is 0. If I put the smallest observation in this sequence as 0, what do I get? I get y equals 0. Now, this is mind-blowingly most important concept in this question. I get y equal to 0. What does that make all the other terms in the sequence? 0. If I had 3 numbers in the sequence, each number would be 0. If I had 4, each number would be 0. Basically, doesn't matter what, if I were to satisfy these three conditions, the mean of the sequence is 0, the range of the sequence is 0, and the first number in the sequence is 0, the only way this can happen is if all the numbers in the sequence is 0. And the significance of that is, since all the numbers in the sequence are same, whether they're 0 or not, since all the numbers are same, the standard deviation is going to be 0. So now I have a unique value of standard deviation, and this question will be sufficient. However, I think it is also important to visualize this not with the algebra, but with logical understanding of how the sequence works. So let's start with the first number in the sequence that is given to be 0, right? And the range is given to be y. So I'm going to write that as y. So this is another way to solve this question. If you have figured out how to get unstuck in statement 1 and statement 2, when you combine those two statements, this is another way to solve this question through only reasoning without algebra. So you're given that the first number is 0. You're given that the largest number is going to be y because the range is y. And you're also given that the mean is y. However, we just talked about a few seconds ago that the mean lies somewhere between the two numbers, right? So ideally, the mean will be somewhere here, right? And since 0 is actually not adding anything to the sum of the numbers, the mean will be closer to y, but not y, right? Even if there were two numbers in the series, then mean would be y by 2. If there were three numbers in the series with 2y, so 0, y, mean would be 2y by 3. So somewhere in the middle. However, the question gives me that the mean equals y. So how is it possible that my mean is same as my range at this point? The only way that is possible is if my y also equals to 0, in which case there is no difference between the 0 and y. They are all kind of collapsed and the mean lies at the same point as all the other observations. Hence, y equals 0. If all the numbers in the sequence are 0, which means all the numbers are same, the standard deviation is going to be 0 because there is no deviation in the numbers. Hence, statement number 1 and 2 combined are sufficient to answer this question. Just to quickly review on what we learned. We learned how to get unstuck in a question like this by using algebra. It wasn't a very difficult algebra. The second we learned is how to reason it out with respect to the range and the observation, especially when the smallest observation was given to be 0. Now, here is my recommendation. You have understood this problem, hopefully. I hope you found this video helpful. All the best with your prep.